Okay. We start immediately. Once again, a very, very, very good evening, ladies and gentlemen, and distinguished members of the Society of Petroleum Engineers, Abuja section. You're welcome to our monthly technical meeting. Of course, this meeting today is on the theme, flare gas measurements for GHG emissions, quantifications, applying value engineering in technology selection. Of course, today we are most pleased and honored to have the managing partner of Flation and Company, Dr. Sunday Kanshu, as our distinguished speaker for today. Let me say a warm welcome to you, sir, and thank you so much for joining us here today, sir.
Thank you so much, Akon.
I would like to also say a warm welcome to all section executives, all executive members of the Society of Petroleum Engineers Abuja section. Speaking of which, I'll start by saying a warm welcome to our amiable section chairman in the person of Madam Amina Dan Madami, who is here present. A warm welcome to you, ma'am. Thank you for joining us here, ma'am.
Thank you very much.
Thank you, ma'am. Also here with us is our amazing programs chair, who actually planned this event for us. A warm welcome to you, Engineer Victor Anoche. Welcome to you, sir.
Yeah, thank you, Akban. Welcome, everyone.
Okay, I still want to say a warm welcome to our moderator for today, who would take over the hosting of the event from me in due time. Warm welcome to our young professionals chair in the person of Engineer Ogenerome Ogolo. Welcome, sir. Okay, I believe he has heard me. I'm seeing his chat in the chat box. I want to say a warm welcome to all of the board members who have joined here present. Thank you for joining us, all the alternate board members. I can see our alternate YP chair, Daniel. Thank you for joining us. Very quickly, you can see on your screen the order of events for today. Of course, we're starting with a safety brief, and by 6 o'clock, we should be done with this lecture. Of course, our safety brief is as usual. First of all, we understand that we are in the times of the COVID-19. Please endeavor to observe strict COVID-19 protocols wherever you are. And if you're driving, kindly endeavor to park your car in a very safe place to partake in this technical session. Of course, if you are home, please endeavor not to carry your phone or your listening device to the kitchen so as not to have a gas explosion. Kindly use the device just in the sitting room or in your living room. And the last but not the least of our safety brief, please, if you're not speaking, endeavor to leave your microphone on mute. Endeavor to please leave your microphone on mute so as not to interfere with any of our speakers here today. Very quickly, we'll be switching gears immediately to the welcome address. Of course, the welcome address will be taken by our section chairperson. This juncture, please help me welcome Madam Amina Dan Madami for her address. Ma'am, please, the virtual stage is yours.
Good evening, everyone. Thank you very much for joining us in this very important webinar. I'd like to thank all of you for joining us, and most especially Mr. Sunday Kanshu for agreeing to give us this very relevant lecture. In line with, which is of course in line with SPE mission of impacting knowledge of the oil and gas industry on its members, adding value and making us more productive. We all know, of course, the climate change issues, UN's protocols around reducing the effects of greenhouse gases. Climate change is such a big issue. A lot of financial institutions are refusing to finance fossil fuel businesses now because it is fossil fuels are the energy industry as a whole is the source of around 3/4 of the greenhouse gases emissions today. So one of the easiest ways of reducing some of this effect is, of course, by reducing gas flaring. And over time, the attempt to reduce gas flaring has been quite difficult. And one of the reasons is because it's very difficult to get accurate estimates of gas flaring. So, and then now with the passage of PIA, it is mandatory for companies to have accurate data on volume of gas so that it can be controlled. So in line with that and all the other issues mentioned, SP Abuja thought that it was very important to have this lecture, and would like to thank Dr. Sunday Kansho, for agreeing to give us this lecture. And I'll urge you all to listen carefully. There's a lot to gain from this. I notice we have a lot of regulators online, which is very good because regulators are actually at the core of all of this, and they are the ones that will ensure that this PIA is being adhered to. They are the ones that ensure the implementation of all the laws in the country. So sit tight while we listen to Dr. Sunday Kansho, and we'll keep our questions until the end of the program. I'd like to hand over back to the MC. Thank you very much for joining us.
Thank you so much, Section Chair, for that short yet incisive brief remarks. Distinguished participants and members of the Society of Petroleum Engineers Abuja section, of course, the moment we have been waiting for is here, the technical lecture. But to handle this section, I would like to most respectfully hand over to our moderator, who would give us a brief of today's lecture, and of course, invite our speaker for today. Please help me welcome to moderate this session, Engineer Ugenerume Ogolo, the Young Professionals Chairperson, to take over. Sir, please, the virtual stage is yours. Engineer Rume, we are not hearing you. You may have to check your device, please. We know your mic is unmuted.
Maybe Engineer Rume will have to log out and log back in. Sometimes that works.
Okay, Engineer Rume, please, we may please have to log out and log in again. And Jerome, I believe your network or it's not allowing you. I think I may have to continue in your capacity, sir. Jerome, please confirm you're hearing me. Your mic is unmuted, but we cannot hear you, sir. So probably you would handle the question and answers. Let's continue with the event, sir. So distinguished members of the Society of Petroleum Engineers, I can see 17 participants already here joined. Once again, you're welcome to this technical session. Of course, we understand that the gas flaring is a challenging issue. And of course, this lecturer today would help us know about this and drive conversations that will be around gas flaring. Of course, we know you will have questions to ask. Kindly keep all your questions in check. You can write them down. Immediately after the session, you will be given the opportunity to ask your question. Of course, our speaker today is the managing partner of Fleischian and Company Abuja. He helps organizations resolve challenges in areas such as natural gas visualization, quantification of GHG emissions, saving potentials from clean energy initiatives, process improvements, hydrocarbon measurements, flow assurance, natural gas transportation, natural gas processing, and LPG penetration. Dr. Kansho also teaches courses in petroleum and gas engineering using case study approaches and helping students see the big picture and therefore understanding the fundamentals. He is a public speaker and coach on effective communications, personal improvement, and leadership effectiveness. Distinguished participants at this juncture, please help me welcome for his lecture, the managing partner of Fleischian and Company Abuja, Dr. Sunday Kansho, for his lecture. Sir, please, the virtual stage is yours.
Good afternoon, good evening, everyone. Akram, thank you so much for the wonderful introduction. I want to thank Engineer Amina Adam Madani for making this possible. I want to thank Victor, who has actually contacted me severally to make this presentation. Once again, thank everyone for joining to participate in this workshop. So let me quickly start my presentation. Please confirm if you can see my screen.
Yes, we can see a screen, sir.
All right. So this evening I have the pleasure to speak on this topic, flare gas measurement for greenhouse gas emission quantification, applying value engineering in technology selection. I know for sure that gas flaring is always a very emotional topic in Nigeria. But what I'm going to say now is that for this presentation, I'm not looking at the emotional aspect of things. I'm not looking at company perhaps maybe not measuring. I'm not looking at all those, but I'm just looking at the data aspect of gas flaring and also why we need to get measurements right for gas flaring in light with the present issue, which we are facing. As Amina said, many lending organizations are beginning to pull back, put stringent conditions to ensure that companies account for flaring. So things like environment, uh, social and governance is becoming a big thing. So companies have to ensure that they measure, they show, not just measure, but also show that they are accounting for their greenhouse gas emissions. Also, this lecture is not necessarily about greenhouse gas emission, but of course, I will try to show you the component of greenhouse gas emission that requires a continuous measurement of flare gas. So, let me start by giving a kind of an overview of gas flaring and why is gas flared. So, gas flaring basically is a controlled combustion of natural gas through what is known as flare stack. So, flare stack is basically a combustion device that engineers in the field in a controlled way burn or get rid of gas that perhaps there is no economic use for it, or there are no facilities to use it. So the gas flaring could be routine flaring, it could be intermittent. So routine flaring is basically when the gas is being flared continuously because there are no equipment to economically transport the gas or commercialize the gas. Intermittent flaring basically is usually for sometimes like blow down from an event when the system is overpressurized or during like wet testing. So, but let's just go into why gas is flared. So basically, in general, flaring, if it's not continuous, is for safety reasons. For the sake of environment and the personnel and also the facility, we have to get rid of excess hydrocarbon. So the best way to do this is to burn the hydrocarbon. For the environment, allowing methane to flow straight into the atmosphere, it's even worse than burning it. Very soon you're going to see what I mean by that. Lack of infrastructure for utilizing the gas is also main reason. If you go to most of the oil fields, they are located in very remote locations, and these locations are far from the market, and therefore, for you to take the gas to the market, you need to, for example, build like pipeline infrastructure or process system to be able to process the gas and transport the gas via the pipeline into the market. But sometimes the quantity of the gas obviously does not support the economic utilization or economic, doesn't make any sense in terms of economy for investing in utilizing the gas. Sometimes there is totally lack of market, so no one knows what to do with the gas. But of course, remember that we need to keep on producing. One thing I have to also mention is that whether it is associated gas or non-associated gas, flaring is common. So, but especially for associated gas, whereby we produce crude oil, in the course of producing crude oil, we have gas coming out of solution. That is even worse because usually at the beginning of the project, the operator may not even have a plan for utilizing the gas. I know now that DPR is making it mandatory as part of the requirement right from the development plan that operators should have a plan for utilizing the gas. But in reality, if you go to most of the fields presently in Nigeria, you can see clearly that from the beginning there was no plan for gas utilization. Hence, there's flaring, because our country we depend on oil. The budget is made of is designed for oil production and the oil price. Therefore, we have to keep producing and as we produce, then we have to flare. Sometimes we flare because of faulty equipment, process offsets, and sometimes as a result of improper operating procedures are not being followed. So, as part of the overview of gas flaring, the next thing is that, what are the sources of flaring? So, when we're doing wet testing, that the flaring could be coming from wet testing. In that case, we have excess gas and we need to get rid of it as we test our wells. Crude oil production, associated gas, that's very common. You have gas conditioning. So at even gas conditioning plants where you produce natural gas liquid, of course, we have to flare because sometimes because of the process offset, sometimes because we intentionally need to do some maintenance. Therefore, we have to plan and get rid of gaseous hydrocarbon to be able to carry out maintenance. LNG production. For most of the people who have gone to places like Bonin, you can still see that even within right in LNG, there is flaring. But that is not to say that they are doing something that is bad. It's just the fact that is a part of the design of the plant that flaring has to go on, because the gas, instead of venting the gas into the atmosphere, we need to burn the gas so that we don't put methane directly into the atmosphere. Methane is 25%. As I said, 25 times worse than carbon dioxide in terms of global warming potential. Pipeline operation, again, crude oil refinery, in all these places, gas flaring is usually part of it. So the next thing is gas flaring as a source of greenhouse gas emissions. So I'm sure maybe someone is wondering what is a greenhouse gas. So greenhouse gases are those gases that have the ability of trapping heat in the atmosphere. Therefore, instead of the heat staying far away from the earth, then we now get the effect of the heat. So some of these greenhouse gases, in fact, typically greenhouse gases include carbon dioxide, methane, and nitrous dioxide. And also you have things like fluorinated gases. Basically, some of these gases you use there in AC, they are also part of the greenhouse gases. They are even more potent, just that their release is in very small quantity. The largest greenhouse gas is carbon dioxide, but it's not as worst as like methane, for example. But the quantity of carbon dioxide is much more in the atmosphere. The next thing again is, so how does gas flaring emit greenhouse gases? So gas flaring is purely a combustion process. So basically an oxidation process, or if you want to put it, it's chemical reaction. So now I'm beginning to remind you of chemistry. You see, when you subject methane, for example, to combustion, react methane with carbon dioxide, what you produce, with oxygen, what you produce is carbon dioxide as a byproduct and water. Also, if carbon dioxide had oxygen react with propane, for example, you still produce carbon dioxide and water. So basically, during combustion process, oxidation is taking place. As a product of that oxidation, you have carbon dioxide. So the other question is that, so what about methane and nitrous oxide? So methane is usually as a result of incomplete combustion. So during the operation of the combustor, otherwise known as flare tank, we may be overloading the flare tank. We may be operating the flare tank beyond its design capacity. Therefore, instead of the methane or the hydrocarbon undergoing total combustion, it undergoes partial combustion. Therefore, some hydrocarbon, methane, or even heavier components, they slip and go out without going through the combustion process.
Madam.
Also, the design of the combustor or the flare system we perhaps may not have gone through a thorough engineering, or maybe during the manufacturing. It wasn't properly produced or fabricated. Therefore, it's not achieving complete combustion. So methane and nitrous are basically a product of incomplete combustion or poor combustion. And someone may be asking about carbon monoxide, because we know that sometimes we have carbon monoxide in combustion. Carbon monoxide is not necessarily a direct greenhouse gas, but then carbon monoxide have the ability to react with hydroxyl group. If you remember chemistry, so hydroxyl group like OH group in the atmosphere. Usually, methane cannot stay in the atmosphere for very long time, maybe beyond 100 years. Therefore, it will be breaking. It will undergo reaction with OH group, but because carbon dioxide do also react with OH to form weak acid, it then limits the amount of OH available in the atmosphere, and OH is not in the same level in every part of the earth. Similarly, carbon monoxide is not the same level everywhere. Therefore, having carbon monoxide in the atmosphere is not good for the presence of methane, because it will limit the amount of OH minus that is available for a reaction with methane. So you have not seen that during combustion, during gas flaring, carbon dioxide is produced, methane is also produced, and nitrous is also produced. Carbon dioxide is naturally a byproduct of the combustion process, but methane is as a result of incomplete combustion or methane that do not go through the process of combustion and slip through the combustion process. Now, so the next thing we can look at is the international climate policy. So these are some of the things that the oil industry have to start looking at it more closely. Having worked on similar projects, I've seen that usually people in the environment are the ones who understand what is going on with some of these policies. One is the United Nations Framework Convention on Climate Change, which Nigeria is a signatory. There is a requirement under UNFCCC that every country, the country that are member or party to the convention, are required to produce every 4 years what is known as national communication. So this national communication is a statement of greenhouse gas inventory. So how much is greenhouse gas, for example, Nigeria producing from all the sectors? So there is another, if you like an organization under United Nations, which is called Intergovernmental Panel on Climate Change. It's a scientific arm under United Nations that develop knowledge for reporting greenhouse gas inventories. So they have like 4 classifications of sources of greenhouse gas emissions. So a country that is signatory to the United Nations Framework on Climate, United Nations Framework Convention on Climate Change, that country have to produce a statement of inventory of all these sectors. So these sectors are energy sector. So energy sector, like the oil and gas industry, is under the energy sector. Power sector is under the energy sector. So, for example, in oil and gas industry, the oil and gas industry, during the production of oil and gas, there's flaring. So emissions from flaring is reported. There is venting of gas, and there is also what is called fugitive emission. Fugitive emission sometimes can be confused with flaring or venting, but fugitive emissions basically are unplanned release of gas. For example, when we install equipment at flanges, we may be having some gas leaks at flanges. Those are fugitive emissions. We would not plan for that to happen. Then you have like agriculture sector, or what I call affluent sector, agricultural land use, forestry sector, and then the waste sector, because usually we generate a huge amount of waste, and waste also produce emissions, carbon dioxide, methane, and nitrous dioxide, all those generated. So there are 4 sectors. So each of these 4 sectors has to be reported in the activities, the emission inventories from these 4 sectors has to be reported in the national communication. Nigeria has produced 3 national communications. One was produced in 2003, the second was produced in 2004, and the third recent one is in 2020. So last year, and it was released. Also, I'm sure you know the nationally determined contribution, which Nigeria has also promised. So basically, the national determined contribution, I think, it started during the Paris Agreement. So as part of the ratification of the Paris Agreement, the government of Nigeria agreed that without being supported from foreign bodies or external support, Nigeria promised to reduce emissions by 20% from the what I call baseline value. In fact, the baseline value now is 2018, and the total emission for 2018 was, I think, 347 million tons. Of that 347, I think fugitive emission, which in this case includes gas flaring, accounts for, the energy sector accounts for I think 60% of emissions, basically emission in Nigeria, and fugitive emission, which is basically is loosely classified in this case in the document that is in the intentionally determined contribution, nationally determined contribution document from Nigeria. That accounts for like 36% of emissions. So there's a huge emission from the oil and gas industry, which explains the reason why companies are finding it difficult to access money now. Whether it's gas, whether it's oil, our sector is heavily emitting. So emission quantification. Emission quantification is one thing that is not necessarily complicated, but it's also complicated in the sense that we have to determine some parameters for us to be able to quantify our emission. At the moment, my understanding is that whatever numbers you see out there in the internet or in a report, as emission in Nigeria is loosely estimated, and that estimate could mean that is overestimated or is underestimated because the baseline data is not strong. I recently worked on a project that we require to estimate emissions from the household sector. Data is a very huge challenge. So how do we estimate emission from flame? So there are various methods of estimating emissions. So there is 2006 intergovernmental protocol panel on climate change. This guideline tells us the methodology for quantifying, and there are several other documents. In fact, huge literature on this. So, but in a simple way, for you to quantify emissions. So in this case, if you see on my screen, the formula defines what is known as a carbon dioxide equivalent. So carbon dioxide equivalent is all the other greenhouse gas emissions. In this case, methane and nitrous dioxide are brought to the level of carbon dioxide. So using what is known as GWP, which is what is basically called global warming potential. So the global warming potential is a factor that relates the seriousness of emission of other greenhouse gases as compared to methane. So for example, as compared to carbon dioxide. So for example, carbon dioxide methane is 25 times potent in terms of global warming potential compared to carbon dioxide. This value is usually published by the Intergovernmental Panel on Climate Change. So we need to know for the flaring there is also what is known as emission factor. So the emission factor is basically the amount of the greenhouse gas that is emitted divided by 1 cubic of gas at standard condition. So this emission factor has to be determined, usually determined by experiment. So there are about 3 tiers, like tier 1, tier 2, tier 3 of emission factors. So if in your own country you do not have emission factor, and these emission factors are depending on industry specific and sector specific. So emission factor for flaring will be different for emission factor for say burning gas in turbine, for example. So, but where this data is not available, a simple equation like the one that's on my screen could be used. But even this equation, we need to know the volume of gas that is being flared per reporting period. So the reporting period could be 1 year, could be 1 day, could be hourly, whatever. So that has to be reported. So this is where you can see. This is where, clearly speaking, we need to know. We need to measure. So measurement give us this number. So in the literature there are already emission factor for gas flaring. So if you don't have, you can use what they call default emission factors. But the emphasis is for this discussion is on the measurement. So we need to measure to be able to determine how much gas we are sending to the flare, and from that amount of gas we are sending from the flare, if we know the emission factor of that flare, for methane, for carbon dioxide, and for nitrous dioxide, then we can then calculate the CO2 emission equivalent. This CO2 emission equivalent is what we need to report in our ESG report. Gradually, the way the industry is going, banks will begin to ask oil companies to produce these reports. Not just the regulator asking oil companies. I know for now the regulator is keen on measuring the flow, but it's not just measuring the flow, but also calculating the emission. This is becoming a very serious business, especially as regards to getting funding from institutional funders. All right. So what next? So what are the key requirements for quantifying emissions from flaring? As you can see, already we mentioned measuring. So we need to do continuous measurement of gas flow rate. The gas flow rate is required to be able to determine how much CO2 we are emitting, how much methane we are emitting, how much nitrous we are emitting. And then if we know all these three, then we can calculate the CO2 equivalent in million tons from our facility. So this is getting very serious. Also, we need to know gas quality. So with gas quality in this case, as a minimum, we should know at least gas composition, what is the percentage of methane in the gas that we're flaring, what is the percentage of propane, butane, all those other gas components, including carbon dioxide, because usually our gas contain carbon dioxide. We need to report that as well. To do that, we need to have gas analyzers, preferable gas chromatography. I know all this information are in DPR's guidelines, and there are also it's a requirement in the flare gas prevention of waste and pollution guidelines of 2018 produced by DPR, and also it's a huge requirement now in the Petroleum Industry Act. So what I've seen many oil fields is that gas chromatography, especially in the upstream sector, most of the companies, I think this is struggle. Of course, for some companies, even the flow rate measurement is a struggle. So we need to determine the specific emission factors for our equipment. So for our flare spec, what is the emission factor? Because the burning characteristics of the flare spec is not the same for all. So we need to understand the emission factor for that. In fact, I will encourage governments to embark on a study to be able to have industry specific. So for example, oil industry specific in Nigeria, emission factors. Other countries like Canada and the rest of them, they have emission factors for their operations. So it's a good thing that we start to show to the world that we are serious about accounting for emissions from the oil industry. Automating our record is one of the requirements. So of course, the oil companies are required to produce reports, I think, almost on daily basis on what is flared. And if they have any event like blowdown, rest of them, they also have to report to DPR. That needs to be automated to minimize errors. So the next thing, what I want to show you now is this extract from BP. You can see that measurement is highlighted, seriously highlighted, and it's a key. In fact, it's a beginning, because that is where you need to get it. That is where you get the data. So you can see, if you want to learn something, you can learn from other very established companies operating in the oil and gas industry. So, for example, BP is saying that they will install methane measurements at all the existing major oil and gas processing sites and also publish this data. In Nigeria today, flare gas data is, if you want, is a secret. It shouldn't be. It shouldn't be at all. This we have to be open with this. In most part of the world, this is a secret. So what next? We have seen from all that have presented so far, all that I have presented so far, you can see the need for measurement. So the next question is, where should we place the flare gas measurement devices? So assuming we have flare gas, we want to put a flare gas meter in place, where should we place it? So two options. One is to have what is called distributed metering. So the flare gas is coming from various sources. So from gas right from production separator, maybe going to flare, gas coming from other equipment, even the storage tanks, gas coming from crude oil heater, gas coming from many other equipment within the system, if it's in the oil production system, if it's in gas processing plant, gas coming from acid gas removal system, gas coming from dehydration system, gas coming from cryogenic heat exchanger, gas coming from the methanizer, the ethanizer, the protonizer, the debutanizer, gas coming from all those equipment. If you go to any of these plants, you see that there is always a relief system that is all linked back to the flare header. So we can put instrument measurement devices on all these lines and be able to track what each equipment is sending to the flare header. That can be very expensive, but it has advantage. The advantage is that if we want to develop a program to mitigate or to reduce flaring from one source, we can be able to know where is our biggest flare source. Then the other option is, so in this, as I said, in the distributed option, gas can be placed in various locations. So basically placed from the locations where the gas is coming from to go to the flare header. The dedicated flare line, if you go to the whether it's an flow station, you trace all the lines going to a common header that leads to, in some cases, you have a knockout drum before the flare start, whether it's vertical or horizontal. But for flow station, usually I have not seen knockout drum, but for like LNG or gas plants, you see there's a knockout drum to reduce amount of liquid in the gas stream going to the flare header. So in that case, a meter can be installed downstream the knockout drum to measure the total flare gas coming from the facility going to the flare stack, to measure what is being flared. Don't forget, if we are taking, we are also measuring the quality of gas. We can also install. We can also take samples from the same location to be able to quantify what is going into the flare, and that is extremely important. That kind of investment is not a waste. In case we want to utilize the gas, we know the composition of the gas. So that's about allocating flare meters. The next thing is what are the challenges faced by flare measurement system. So one challenge of flare gas measurement is wide range of flow rate. So because sometimes it's not all the gas, in fact, in most cases, it's not all the gas that is going to flare. So some companies may be taking the gas for flare within the plant. Some companies may be sending the gas to a process system where the gas is utilized and it remains small to be flared. So sometimes the volume that goes to the flare is very high during blow down events or depressurization system. Recently, I went to a facility. It's huge blow down going on, like 2 hours blow down. Huge amount of gas is being flared. At that point, the flow rate is huge. So those are the challenges. This is one of the challenges that the flare meters or the flare system, measurement system, have to follow to face. The need for the sensor to withstand high flow rate, and also the flare lines that are usually large pipeline size, so measuring a large pipeline. The requirement, the high accuracy requirement. For example, GPR required that flare gas should meet uncertainty requirement of plus or minus 5%. Also, sometimes the gas composition is not very consistent, especially in refineries. There's installation issues. There's requirement to install under operating conditions. Why the system is being operated without shutting down. Sometimes you have things like wax deposition on the sensor. The other one is the total cost of the meter. I need to try on now. So what are the options? So there are several technologies that we could consider for measuring flare gas. One is Coriolis. Many people are familiar with Coriolis meter. Orifice is what you find. In fact, for everywhere I've been in the oil, the upstream sector, what I see is orifice. Very few ultrasonic. You have Tamamas flow meter. You have insertion vortex meter. You have insertion turbine meter. You have average pitot flow meter. I'm not going to go detail into this, but what I'm going to highlight from this is that the ones you see in green, they seem to be matching those requirements as stated before. They operate in a very wide operating range. So at low flow rate of flare, they are able to cope. At very high flow rate, they are able to cope as well. So I'm progressing with these two technologies, Tamamas and ultrasonic. So the next is looking at Tamamas and ultrasonic. So I will now go into a little bit detail. So what is ultrasonic? How does it measure? So there are two types of ultrasonic meter, flow meter. One is the clamp-on ultrasonic. Basically, the sensors are on the outside wall of the pipe. The other one is inline ultrasonic. So in this case, the sensor is installed into the pipe. It has to have a small contact, stay on the wall of the pipe to have a small contact. It does not get into the flow path. So how does it measure? So basically, sound is sent through the stream of flow, and it tries to. So the sound, there are two sensors, one on the other side, and the other one, on the other end. So it sends a signal. Sound signal goes from one sensor to the other. So the other one is a listening sensor. The other one is the emitting sensor. So it emits sound. The other one listens to the sound and then send the sound back. So the difference in the transient time between the sound movement within the medium is related to the average velocity of flow through the pipe. So if you like, just imagine swimming through a river. So the time it takes you to go through the river depends on the flow of the river. If the river is flowing very fast, it will take you longer. It might take you longer time to flow to the end. So similar thing is utilized here to measure. So it's kind of efficiently measure what is passing through the flow stream. So the measurement here is volumetric. Basically, report in terms of cubic meter per hour, or and that can be converted to per day. And if you want this to report in terms of mass, then you need to install pressure and temperature transmitters to measure the temperature, the operating temperature, and the operating pressure. Then you can then convert the flow rate to the mass. First convert to standard operating standard conditions, and then convert to mass flow rate. The emissions are usually reported in terms of tons. Tons is mass, so that's the reason why this needs to be reported in mass. Of course, the advantage, wide operating range, ton down of 2,500. Basically, it operates at very wide range. At very small flow rate, it operates. At very high flow rate, it operates. It gives good accuracy at all these rates. It's not sensitive to the composition, but it is easy to install. The accuracy is very good, no moving parts. And the disadvantage is that it's quite expensive, very expensive. I've worked on several projects. I've seen how expensive this is. It's affected by liquid drops. I remember having done experiments to measure, try to use ultrasonic to measure gas flow with some droplets. It always gives a signal error. It requires temperature and pressure measurement to compensate for flow at standard condition, and also to calculate the mass flow. The next technology is Tamamas. So Tamamas basically a very simple operation. It works based on the cooling effect. So there are two sensors. One sensor is a heating sensor, and the other sensor is the cooling sensor. So there are two ways to do this. One is continuous heating the sensor while keeping the temperature constant. So the way you can see, imagine is that, let's take for example, you have a boiling ring. A boiling ring is continuously heated, and you pour cold water on the boiling ring. So the more you pour the cold water, the more electricity is being supplied to the elements that increase, make sure that the heat does not reduce. The temperature difference between the cold side of the probe. So in this case, this is a heated element, this is a cold element. The differential temperature across the element is kept constant. So the heating is increased so that once the more flow through, the more the flow is going through the sensor, the more the cooling, the faster the cooling, if you like. But then the more the power being supplied to heat the element. So that has a direct relationship with the density and the velocity of the flow, the volumetric flow rate of the flow. So if you multiply the density multiplied by the volume flow rate multiplied by the cross-sectional area of the flow path, then you get the mass flow. So loosely speaking, that's how the meter operates. And what are the advantages? Again, it operates in a very wide flow range. Probably is one of the cheapest meters you see around. Easy to install, high accuracy across the flow range, no moving parts, low pressure drop, basically no pressure drop. It does not require measurement of temperature because the sensor is already in the temperature measurement device. It does not require separate measurement. It measures the mass directly. So the measurement from Tamamas meter can be fed directly into emission estimation or emission calculating model. So the model the model can be in Excel or could be a software. There are many software in the market. The data from these can be fed straight into it. Of course, there's no flow meter on the surface of the earth that is 100% accurate. There are always disadvantages because these are equipment. So it's sensitive to composition, especially because it depends on the cooling effect of the molecules. So, for example, if you have like hydrogen in your gas, then hydrogen has efficient heat capacity. Therefore, it takes heat faster compared to say methane. So also there could be things like wasp build up on the prop, and then also it has issue when there are liquid droplets. Companies nowadays, manufacturers have devised ways of saying that they can control all this. So talking about cost, how this cost comparison from Fluid Component International. So from here you can see clearly that ultrasonic meter, they are quite, everybody knows they are high-end meters. In fact, they are also the most used. They are the most used in the industry. They are well known, probably because of most of the companies that are making them, they are much bigger. So for across all the diameter, from the small diameter to the large diameter, you have ultrasonic, more expensive, while Tama is relatively cheaper. But if we look at it across, say, 5 years, because what I used to advise people always is don't specify a meter because it's cheap. Now, look at the life cycle cost, say 10 years, 25 years, and see the cost of maintaining the meter. So if you compare that between ultrasonic and Tamamas, the price of the meter on average, ultrasonic 20,000, will be very small ultrasonic, because last time I had a project where an OEM sent me a quote of ultrasonic costing around $109,000. So it can go that very expensive. So if like this is the minimum cost for small diameter. Tama can go like 50,000 high, the maximum price $50,000 dollar. Installation cost 25,000 for ultrasonic. Tama is very, very small amount. Commissioning very small, again 10,000. Tama 2,000. So in all, over 5 years period, you'll be looking at ultrasonic spending like $71,500, while Tamamas will be going for something like $21,500 $1,000. So, concluding remarks, looking at value engineering. So, what do you mean? We can't just, engineers, we can't just go and say, we pick this meter and that's it. We have to do some critical thinking. First, we define our value. What are the value? What are the key things we are looking at? So in Nigeria, for example, first, you have to look at DPR requirements. Maybe in future, DPR is going to be the upstream authority, and also it's going to be the midstream, downstream commission. But you have to look into their requirements. So, for example, the present requirement is plus or minus 5% uncertainty. So, I will pause here and say something about uncertainty. Uncertainty is not just about the meter itself, but about the measurement as a system. So, all the input that goes into the measurement, we are going to evaluate the uncertainty plus the uncertainty of the meter. So, we have to do this analysis and come up with this number. Have we achieved, which meter is giving us what DPR has said, 5 plus or minus 5%. Whichever one that is giving us, if we list 10 of them or 7 of them, as we can see in the presentation, the one that gives us, those ones that give us this uncertainty requirement, we proceed with them. The next thing is we benchmark against the general requirements, range, flow range, robustness, and the rest of the requirements. those ones that pass the test, we advance then to the next thing, analyze the technology over the life cycle in terms of cost, look at the cost over the life cycle. So you're going to ask the OEM or the vendor more questions. What is the cost? How much do I need? And what is the frequency of being proving? How long should, or when should I change the sensor? All those questions, critical questions. Then you add all these costs over say 20 years and then see which one will cost you more. If that cost is in line with your company policy, usually we go for the cheapest one if it passes the technical requirement and the regulatory requirement. Then we say, okay, this meter is thick. So that's the concluding remark on value engineering. And if you like also that perhaps concluding remark from my presentation. So at the start of this presentation, I usually don't like to talk about myself and my company, so I'll leave this to the end. So Flexen is a consulting. We call ourselves an energy infrastructure advisor or a consultant and supplier. So we do consultancy, we do training, we supply flow meters, we do auditing, we do uncertainty analysis. I work with many people know that I work with many companies, and also we are the organizers of the Nigerian Hydrocarbon Measurement Conference. Also, we have a couple of trainings around measurement. So anything you think about measurement, we can organize a training around this. We pride ourselves as a knowledge breaker around hydrocarbon measurement and process engineering. I want to thank you for your attention and be happy to take your questions.
Thank you, Dr. Sunday, for a wonderful presentation on flare gas measurement for greenhouse gas emissions quantification, applying value engineering in technology and selection. I think we've learned so much from your presentation, right from what is the meaning of flare gas to the United Nations stance on flare gas emissions, to the fact that it's not just the method being used to measure flare gas in Nigeria, like you said, that either we are overestimating or we are underestimating, but you went for that to also show us that there are ways in which we can accurately measure the flare gas that is being emitted in Nigeria by discussing some unique technologies. And one very interesting part of your presentation was the fact that you did not just only tell us the advantages or disadvantages of this equipment, but rather you went further to also tell us the economics, which is very key, so that with that, we'll be able to select the equipment or the methods that can be used to measure these flare gas, and that will be based on the size of the company, because for those marginal field operators and the IOCs, they can't use the same kind of meter. So based on the company's capacity, that will determine which of these equipment they would proceed. So thank you once again for a very nice and brilliant presentation. I'm trying to look at the chat box if we have any question here, but we have 2 questions here. I guess you can hear me, right?
Yes, I can hear you.
Okay, yeah. The first one says that because you made mention of that the Petroleum Industry Act says something about gas flaring. So someone asks that, what does the PIA says in respect to gas flaring?
Okay.
Should I go with the second question?
Let me answer this one first.
Okay.
So the PIA, in fact, before the PIA, DPR has done a lot of work around gas flaring, and one of those regulations is the gas flaring prevention Prevention of Pollution and Waste regulation of 2018. So clearly in that regulation, there are penalties for not measuring gas flaring, and also there is cost for flaring. So if you are flaring, there's a ban. If you are flaring, I think below 10,000 barrels per day, or if you are producing below 10,000 barrels per day, I think it's something, I forgot, it's I think below $2 by 1,000 square feet. So PIA, what PIA does basically, if I remember, is to anchor its question for if you like strengthening that regulation basically. So PIA is linked to this regulation that already exists for gas flaring. So it what it says is it states the requirement for it emphasized that those requirements in the regulation of 2018, and in that regulation of 2018, that regulation also referenced the DPR guidelines for measurement, which was released in 2018 as well. So those things are actually linked. But what I'll summarize about that is that there is a clear provision that seems to be very serious on gas measurement, flare gas measurement and reporting. I don't know if that answered the question. So the
okay.
Second question, please.
Okay, thank you. The second question here is, among all the gas meters you talked about, so the person is asking, which of them do you recommend to be used in Nigeria, considering the Nigerian environment? Thank you.
Okay. Usually we, as I said, as you can see the presentation, value engineering is the key. Therefore, I cannot tell you use this meter, don't use this meter. I can only say that if I cannot publicly, for example, in this lecture, tell you use this meter. So because one thing with measurement is that there are many options, and each option seems to be claiming that it's correct, it's good, it's accurate. Also, there are also commercial interests. So because of commercial interest and because of many options, even the regulator cannot really use this one. So it gives you the requirement and it gives you the various options. So based on that, I cannot tell you that use this option. Even though I promote companies that sell meters, but I almost like promote every technology. So I can't tell you that use this one. But if you are to consult me based on your requirements, I can also not just qualitatively say use this one. I have to do analysis. So, but as you can see clearly in my presentation, when it comes to flare gas measurement, two technologies are distinguish themselves well. These are not company specific. These are principles. So anybody can design a meter today based on ultrasonic principle. Anyone can manufacture a meter today based on Tamamas measurement principle. So, but these two meters, they kind of satisfy the requirement for flare gas measurements. So, if I want to recommend anything, I would recommend between ultrasonic and Tamamas. But then to say go for this, we have to do deeper thinking.
Thank you for your response. Yeah, it does. Lastly, the last question we have here is based on marginal feed. That how do marginal feeds with small budgets meet regulatory flare requirements?
That's a great question. So small budget. So you can see clearly I have this comparison here. Sorry, just give me 1 second. I think just not just to confuse people. I think that an S is missing here. So there's comparison here. So if you're going to go by budget, you know which one to go for. So as marginal feed operator, you're going by budget. First, you must meet the uncertainty requirement by the regulator, and then you think about your budget. Okay. So for a small budget person, I would say pick all the technical requirements, regulatory requirements, and go for the cheapest one.
Okay. Thank you for your.
If we need to have insight into how some of this costs, you can contact me offline, and I can give you more data in terms of cost, ballpark cost for all these meters.
Hello.
Yes.
I'm sorry, I don't know. I actually sent my question, but I discovered that I sent it to the wrong. I didn't send it public, so I don't know if I have your permission to ask, since we're already rounding up. Just a quick one. Moderator.
Yes, go on.
Okay, please. I wanted to ask, because you talked about the problem we have in Nigeria, that we have problem of the accurate data. Now, who is responsible? Is it the DPRO or the oil companies? And what is Nigerian current situation in terms of data? Like, is everything normal, like the way we are doing it? Because there must be reasons why we are not having accurate data. So is the fault from the company, or DPRO is not enforcing, the laws?
Well, that's an interesting question. So, first, I'll start from the DPR. Not speaking for DPR or anything is that, because what I do perhaps as a consultant is to look at the documents that are available. So I don't go asking companies in terms of compliance or in terms of enforcement. So if I'm going to talk about what the DPR has done, especially in the past 3 years, the flare gas prevention of waste and pollution regulation of 2018. Of course, in the last 3 years, was to address some of this confusion, and that was again, that was DPR work. The guidelines for quantifying for quantity and quality measurement guidelines, which has gone through several editions. The latest edition covered is the one that has this uncertainty requirement for gas flare gas measurements. Again, it also said clearly the penalties, the regulation 2018 of flare gas set all the penalties, and also the cost, the price companies will pay for flaring. So based on that, I will say that if a company is not reporting based on what the regulator has said, in that case, it's the fault of the company. So the other one is whether it's being enforced or not enforced. I don't have data to know that. But what I know is that there's documents that guide. There's a legal document, and then there's a guideline that supports the legal document. So I would say that the government on its own part, represented by the regulator, if you like, has done it. The oil companies need to do more. at the moment, it's not just about regulation, but also it's about the business. So about the business is in two ways. One is being able to access development funding to, for example, to invest in gas projects or oil projects. That is now because of the push for energy transition, the push for net zero. There is this requirement from external forces. So the oil companies need to do more, apart from the regulator. The regulator will punish you, or if you are flaring, you pay for flaring. And even the flaring now is huge, even though it's tied to what you produce. In terms of accounting for that, the oil companies have various ways to make sure that they don't pay much. For inaccurate data, the inaccurate data is double-edged sword in the sense that if a company is reporting is not measuring, for example, or is using things like orifice plates to measure, put in a gas flare line to measure the flare rate, what will happen is that the company will be over-reporting how much is flaring because of the meter overreading. In fact, orifice flow meter overreads when the gas is wet. When you have wet gas, it overreads. And usually, flare gas in most of the oil field I've been to is wet. So there's chance that companies overpay for flaring. So in the end, I would say that for the best practice and good business require that a company should be environmentally responsible. So it's not necessarily just about the regulator. I know you probably don't. You will not be happy with that.
Thank you, Dr. Sunday. But you see, DPR is a business enabler. We give the companies an enabling environment, to improve their business, business processes. So I think they should be the one, because really they'll be paying more if they don't monitor their emissions properly.
Mm-hmm.
Well, I'm not the best person to speak on this. We have Mr. Odafe, who is in DPR. I don't know whether you would want to add something, please, to this. He's the right person to speak on this. He's of HSE in DPR.
Yeah.
Sorry, I just went out a bit and I heard my name as I just came back in. Do you want to just bring me up to speed on what you want me to speak on exactly, so that I could do justice to it? Thank you.
Moderator, over to you.
Can you hear me?
Yes, I can now. I know I heard my name and you wanted me to speak to something. What is it exactly?
Yeah,
I could.
A question was asked in respect to the regulation of gas flaring in Nigeria. That
yes.
what has DPR been doing? As companies been complying to it? Because the speaker also made mention that either we are overestimating or we're underestimating the amount of gas that is being flared. So we want to know, has there been compliance from the company, and what has DPR been doing in respect to the regulation of flared gas? Thank you.
Okay, so basically it's, thank you very much for the recap. So basically it's twofold action so far. As you're already aware, there are several regulations and statutory provisions that prohibit gas flaring as well, but we all understand our industry that when a lot of these facilities were designed and became operational, they did not put capacity to manage the associated gas that comes with the oil produced. So flaring goes on. But over time, we have released several regulations to make sure that companies who flare have to retrofit, redesign, as it were, to manage the flares. Of course, there are fines and penalties for flared gas. We also have the gas network code, as you're already aware, on programs that are on all the gases that hitherto have been flared are utilized domestically to produce LPG. So remember when I said twofold. So the idea is not just to stop flaring, is of course to reduce contribution to greenhouse gases. So in terms of compliance, yes, there has been an increased, I can say very much increased level of compliance from the industry. And currently we are even, we started what we call methane management from the environment side that has to do with leak detection and repair programs across the oil and gas value chain. Of course, we're starting on the upstream first. So a guideline has been developed already. It's undergoing reviews internally. All companies have been required to look at all the equipment that they have and calculate their methane release potentials and all that. So there's a lot of data gathering ongoing. Guidelines have been drafted. So the push is to ensure proper measurement, because if you don't measure, then you will not know what you're emitting into the environment. And that way, you can now begin to in place leak detection and repair mechanisms for all those assets that show indications for release into the environment. So yes, in a nutshell, compliance has increased over time. There's a lot to do, and we're still doing that as well. So once the guidelines are released, there will be a strategy to manage and monitor as well. Fines and penalties still, even though they are the last resort, we still rely on them. But overall, there has been an increase in compliance in monitoring and managing greenhouse gas in the oil and gas industry currently, as compared to where we're coming from. And what we're looking at is to ensure that maybe not net zero in the nearest future, but of course, very possible. We're also working together. I must also add, working with the Federal Ministry of Environment, of course, on looking at our nationally determined contributions for greenhouse gases and all those climate change issues, short-lived climate pollutants, anything that's across the oil and gas value chain that contributes to greenhouse gas. The DPR is seriously on. We're on top of it. We are working closely with our partners as well, and I would say the industry so far has been very cooperative as well. Thank you.
Thank you a lot for your response. I think with this, we'll bring the questions and answer session to an end. Once again, Dr. Kanshu, we appreciate you for your response to the questions, and most especially for delivering this nice and intellectual presentation today on flare gas measurement for greenhouse gas emissions, quantification, applying value engineering in technology selection. So at this point in time, permit me to invite Mr. Akpan again to close the session for us. Thank you.
Thank you so much.
Thank you so much to our amazing resource person. Thank you so much for the session on flare gas measurement. Of course, we're switching gears immediately. For those just joining us for the very first time, we can see there's a lot of comments in the comment box, appreciating and saying thank you to the lecturer for today's session. I can see Jubil Hassan saying, very insightful presentation. Thank you so much. I see a chat from several other persons who have joined, most especially somebody that just joined for the first time today. Thank you so much, Muftahu Ojulari. I see your comments, first time of attending a technical session of SP. Kudos, thank you so much for joining. Of course, sir, you could send your email privately to us so that you can be updated on our future technical sessions. I would like to also say a warm welcome. I'm made to understand that a distinguished lecturer of SPE International Engineer, Dr. Michael Adegbite, has joined us. Thank you so much, sir, for joining us. And of course, all other board members, Nana Rim team, and other board members of SP Abuja section, thank you for joining us. Should you be joining the very first time, please be informed that you're please advised to be a professional member of the Society of Petroleum Engineers Abuja section. We are inviting you. Of course, you can see the link to join there. There are several member benefits being a part of SP, from discounted event registration, special pricing on books and subscriptions, discounts on SPE papers in the One Petro Library, and subscription to the Journal of Petroleum Technology. Of course, you also have student members benefits, which you can see, which is displayed on your screen. So please, we are advising you to join. Kindly send an email to spabuja@gmail.com or an email to our membership chair at ek.okafor15@gmail.com. Of course, we are on several social media platforms. This event and our past events are always streamed, are available on our YouTube page. Kindly search SP Abuja section 119 on YouTube to have all of our past catalogs. We are available on Facebook, on LinkedIn, on Instagram, where you can be updated on all of our session activities. So we are please calling that you join and be a part of SP Abuja section. Now, we have information from our council chairman, Professor Olalekan Olafuyi, which you can see on the screen. We are doing a survey. We are conducting a survey that will help us to introduce new events to the SPE NAIS in order to improve the way NAIS is delivered. So please kindly type the link you see on your screen. Kindly type the link you see on your screen and endeavor to be part of the survey. Of course, to help us, the link is also in the chat box, which I've just posted. Kindly endeavor to go on the chat box, click on that link, and please be part of the survey. We want to know if you would like NAIS to remain as it is or we should improve on it. Of course, we also have an upcoming event coming up on the 1st of October. It is organized in partnership between the Platform for Innovation and Productive Ideas and SP Abuja section. It is a quarterly webinar. The theme for this is the future of the energy industry, the skill sets that will matter. You're please once again advised to be part of this webinar. Of course, the registration link is in the chat box. Kindly endeavor to click on the link in the chat box to register. Of course, I've just dropped 2 links on the chat box. First for the survey, and the second link on the chat box is to register and be part of this webinar. The link and everything is also on our social media pages. You can go over there and click on the link on LinkedIn and be part of it. At this juncture, please, we would love to most respectfully welcome for his closing remarks our program's chairperson, Engineer Victor Anoche. Sir, please, the virtual stage is yours.
Okay, thank you, Akban. I want to quickly thank our session chair, Engineer Amina, and the entire board members of SP Abuja session for approving this event. And special thanks to our speaker, Dr. Sunday Kanshu, for exposing us and teaching us about the overview of gas flaring and the step to emission quantification. So thank you very much, Dr. Sunday Kanshu, and I'm sure all the participants actually benefited from this event. So I would also like to thank everyone that participated in today's technical lecture, and to tell you that SP Abuja is committed to giving us more technical events, both for our members and for the general public. So as we end for today, I would like to encourage us to participate in our upcoming meetings. We'll be having interesting program in October, and also a DL in November. So on behalf of the entire members and board of SP Abuja session, Thank you very much, and have a good evening. Akpan.
Thank you so much, sir. Okay, to end the event, please, I would love to most respectfully request that we turn on our video cameras for a quick photo session. Of course, this is time for networking and of course, meeting one another. So please, I advise that please you turn on your video camera. Let's have a very, very quick snapshot for our media purpose. Thank you so much. Kindly on your camera. Thank you so much. Thank you so much for joining and staying till the end of this session. I can see our section chair. I can see our programs chair. I can see Abdul Rafi. I can see Taiwo. I can see Imobon Uto. I can see Engineer Dr. Michael, additional lecturer. Thank you, sir, for joining. I can see Akeem. So please endeavor, moderator, sir, Engineer Rume, I'm waiting for you to turn on your video camera. Aisha Taku, thank you for joining us. Thank you so much, ma'am. One of our board members.
Thank you.
Okay.
Thank you, Akpan.
Okay. So at this juncture, Your Excellencies, distinguished members, we come to the networking session, and in 5 minutes time, we end the meeting. Thank you. Section chair, over to you, ma'am.
Am I supposed to do something again?
we still have Dr. Michael around.
Oh, okay. Good evening. Good evening. Good evening, distinguished lecturer.
Good evening. Thank you
very much for joining us.
My pleasure.
We really appreciate.
Thank you very much.
Thank you, sir.
Thank you for having me.
Thank you.
And Mr. Odafe, thank you.